No? I think so. Okay, so we're going to play off of what we just did. I don't need the volume on it anymore. Madeline, you said we're going to take a triangle that we knew the base was 25 and the altitude was, what was it, 17?
Yes.
17. And we want to compare that to a triangle. Could be bigger, could be small. Well, we know it's smaller. 15 and the height h. And you said then set up a proportion of 15 over 25 is equal to, what was the area of that triangle? 212.5, and use that to find the area of the other triangle. Okay, so we're just going to leave that sit there for a second and do this. Let's suppose I have a little square, and that square has a side length of 2. And then I have another square that has a side length of 5. Okay. What's the scale factor between those two squares? 2 over 5, correct. So we could do something silly like, well, I could do this. How long is that? 2 radical 2. That's a 2. 45, 45, 90 triangle. We could use proportions to solve for the diagonal of the other square. In other words, we could do 2 over 2 radical 2 is equal to 5 over x. Cross multiply and solve, and we will find that x is how big? 5 radical 2. Right. We'll save you the hassle of having to do that. Okay, good. So remember, anything that you measure with a ruler, when figures are similar, will be in that same proportion. So if I want to do the perimeter of the smaller rectangle, that's a square. The perimeter of the smaller square is 8. So I could do 2 over 8 is equal to 5 over x. Cross multiply, I get 2x equals 40, so x equals 20, but that's something you already knew. So we're confirming what we already knew, that anything that can be measured with a ruler falls under that proportion. What's the area of that guy? 4. What's the area of this guy? 25. Okay, so changing colors because this is important. 2 over 4 is equal to question mark 5 over 25. Cross multiply, confirm. What do you got for me?
No.
That might require a little more explanation than just no. What does no mean?
No, 50 doesn't equal 20.
No, 50 doesn't equal 20, so we made a mistake. And where's the mistake we made? Well, this is the key to what we're talking about today. This is called FTS. FTS, which stands for Fundamental Theorem of Similarity. Similarity. FTS. Anything you measure with a ruler, good to go. Anything that measures area, not good to go. It doesn't work. So we need to come up with a different formula. What is the relationship here? I should be able to figure that out, right? I mean, obviously I know the area of a square is 25, but let's suppose they weren't squares. Let's suppose they were just 2 blobs that were similar. And I knew the relationship between the 2 blobs, also known as the scale factor, and I know the area of one blob. How can I find the area of the other blob?
Can't you set up a ratio?
Good.
Or a proportion?
Good. I tried that though and it didn't work. So I need a little something in order to get it to work. Let's go to the next slide.
Wait, fundamental what?
Theorem
Theorem
of similarity. Okay, so we got blob number 1, we'll call that B1, and blob number 2, And we know that B1 is similar to B2 because I told you. And we would know the ratio between those two things, so we'd have to have some linear measurement. We'll call the linear measurement from this guy L1, and we'll call the linear measurement from this guy L2. Okay. Now, that can be whatever you want. Maybe we know the perimeter, maybe we know the distance across the block, I don't know, whatever. We have some linear measurement. So we can set up this L1 over L2, which is our scale factor. Our ratio of similitude. Have I used that word before?
No.
Okay. So this is our ratio of similitude. Similitude. It's our scale factor. Okay, those are the two most common terms. We're probably going to use scale factor, but occasionally that ratio of similitude pops up every once in a while. Now we have to figure out a way to figure out, if I know A1, how do I find A2? So let's go back to the squares. 2 and 5. Area here is 4. Area here is 25. Anything for me? Because we know, just to refresh from the previous slide, we know that 2 to 4 is not equal. Actually, you know what? I'm going to write it a little bit differently. Maybe this will help. Oops, wrong thing. I'll just erase the whole screen. That would have been bad. Let's do it this way. Let's do 2 to 5 is not equal to 4 to 25. So we can't compare directly linear measurements to area measurements. Need to come up with, somebody just had an epiphany. Go.
Is the area measurement the linear measurement squared?
Nice. Now, can you put, this is the hard part. You just hit the nail on the head. Now the hard part is, can you put that together into a formula? Using not this stuff, but these 4 buggers over here. Hi, Lois.
L2 over L1 squared.
Oh,
Or quantity squared.
I'm gonna flip it over.
Oh,
Is that okay?
Yeah. Is equal to A1 over A2.
Woo! Let's give it up, huh? Well done. If you'd like to rewrite it, you could do L1 squared over L2 squared is equal to A1 over A2. That, or this, is part 1 of the 2-part fundamental theorem of similarity. We'll get to the second part next chapter. Okay, so let's check it. If we use what she just said, we should be able to do 2 over 5 quantity squared should be equal to 4 over 25. Oh, look at that. She's so smart. Good. Going back to the problem that we just did on that AP question, many of you attacked it by recalculating the new area. Or one way you could have done it is do what we started doing by, I think I got it here. Yeah, start by calculating what h is, and then recalculate the area of that triangle. Okay, that would work. So we would do 15 over 25 equals 15 over 25 equals h over 17. Recalculate, figure out what the height is, then do the area of the second triangle. However, the fundamental theorem of similarity allows you to not go through that calculation. So you're saying, well, why can't I just do this all the time? Because what happens then when we have blobs? So I don't know any measurements on those blobs. I don't know how to find the area of the blobs. I just have a bunch of information. So let's go here. We've got, let's see, L1 is 6. We'll do blobs again. Here's B1, and try to make that similar looking. B2, and again, B1. You need to know that they're similar, by the way. You can't proceed if they're not similar. And what do you want L2 to be here, Emily?
8.
Oh, that's fine. Okay. Don't trust the picture. Right?
Oh, right.
Right, okay, good. What do you want the area here to be?
14.
14. Okay. Calculate A2. 4 parts in that problem, 4 parts in that equation, 4 parts in that proportion. You need to have 3 of the 4 in order to solve it. And yes, you will need your calculators. Because the numbers don't get up. Sorry. So this is a scenario where you have to use FTS because we don't know anything about calculating the area with blobs. Sometimes you can get away with it in geometric figures, but in this case, you got to do it using the theorem. By the way, will the answer be bigger or smaller than 14? Bigger, correct. Because again, don't trust the picture, trust Emily's numbers. Way to confuse everybody. Good job. Is that it?
Yeah.
Come on, girl. Esta es su máquina de matemáticas. En su casa. Niet zeer goed voor de chance.
Don't you swear this, but.
That sounds like you're trying to cough up something.
We both got 24
Beautimus.
and then figured out what this
We heard from her. Alex, tell us what you did.
Makes pizza. On a
So since L1 is 6, I put 6 squared on top and 8 squared on the bottom.
I like it.
And set it equal to 14 over 82.
Good. I like the fact that you stayed with the notation there. Okay. I think it's easier to set it up that way. Some of you may have set it up as 6 over 8 quantity squared, but this one works a little bit better. I just find it easier to solve. 36 over 64 is equal to 14 times A2. I'm assuming you cross multiplied then, divided by 36, and A2 turned out to be
24.89
24.89 what?
units squared.
Units squared, good. Well done. We good? Any questions on that? Okay, let's change the problem. Let's get rid of that. Ooh. Okay, Simon, how big is this blob?
25.
I give you free reign and you give me 25, a perfect square.
1,671.
Attaboy. What are my units here?
Centimeter.
meant the other one.
Centimeters squared, good.
No, the other one is.
No.
No.
That's actually
I don't want you to have that much free reign.
Um,
Simon, how big is L? That's a 1. L1.
6,243.
100.
Wow.
Okay.
0.5.
I'm gonna sue.
Oh,
It's too late.
No.
It's too far to go to the eraser.
Yeah.
And what's the area of this guy?
6,240.
Shut up, Machek.
Okay. 3,471 centimeters squared.
Good. Figure out how long that blob is.
Oh my gosh.
It's 100 times 100.
Will it be bigger or smaller than 100?
I don't think so.
Smaller. Good.
And the number's gonna be ugly.
I'm going to talk while you're calculating. You'll notice I shifted away from geometric figures and I'm just focusing on blobs. Why? Because I want you to get out of the habit of wanting to automatically calculate area of geometric figures. So like I said, that last triangle problem on the AP question, you could very well go ahead and calculate the area of the triangle using the geometry, but if you use the FTS, things go a little bit smoother once you understand the theorem.
Keep it flat.
He's so advanced, he doesn't even know how advanced he is.
It's easier if you square the other side.
Oh, you didn't square root it.
Not until the end. It's simplified. You make it harder. Did you finish that? Did you finish?
Yeah, but I know I did it wrong. That like one.
Okay, got it.
Sarah, how'd you set it up?
I did 100 squared over L2 squared equals 3,471 over 1,671.
Okay, now let's talk about how did you solve this?
So I squared 200 and I got it to 10,000 and I cross multiplied the two because now there's still L2 squared, but I just left that so I can let square root.
Okay, so let me show you another way to do it. If I multiply across, I get 3,471 times L2 quantity squared equals 100 squared times 1671. Okay, so here I don't have to write out all those big scary zeros and multiply by 10,000. Then divide by 3,471 and I get 100 squared times 1671 divided by 3471. Now the reason I did that is I don't have to write out big scary numbers and I can plug this into my calculator as is. What is this number, by the way? You said?
69.38.
That is incorrect.
4,814.14.
What's the last step you need to do to get L2 by itself, Sarah? How's it, baby? Square root. We take, whoops, we take only the positive answer. What do you got, Sarah?
69.87.
And notice that's centimeters, not centimeters squared, because it's a linear measurement.
No, 3.8. 3.9. It's 3.8.
Yeah.
No, it's actually 88.
Three
Yeah,
eights.
that's right. 88.8.
That was a good one.
That's perfect.
And you have to change this to
No,
69.38. Oh, Took a while. It's okay. We got there.
Okay. Beautiful. We have 4 minutes, one last thing. Let's go to a different slide here. Okay, and let me pick on Christian, we're gonna pick on you. How tall are you, Christian?
Like 5'10" maybe.
Lies.
In inches?
7.
Lies.
Maybe if you're a booger, Mr. Festival.
What do you weigh, fatty?
Like 120.
You realize my right leg weighs 120. 120. All right, so here's the tough one. I don't know if you're going to be able to tell me. But
You're 160.
if you go down to the weight room right now, rack up some weight, and crank out just like one monster bench press. Like, what's your max on bench?
I have no clue. Probably around like 10,000 pounds. Let's be more realistic.
I'd be surprised if you lift a lot.
Do any of you gentlemen know what your max is on bench? Yeah, but I don't want to use you. Because I don't want to ask a girl how much she weighs. Make me awkward. Unless any of you females want to give it up. All right, excellent. I don't know if I've ever done this experiment with them.
I don't know. Are you serious? Probably
Too much. If you weigh like 120. I'm definitely.
I spell that right? Good. How tall are you?
63.
Thank you. I can't ask. Okay. I would just have a seizure and fall. All right. What can you bench? How much? Atta girl. Nice job.
45 on each side.
Okay.
bar.
Just the bar. First you throw your hips up in the air and it's Okay, so here's the question. She goes home tonight. She's running late. She had some activity going on after school. Whatever. She gets home late. Family's already eaten dinner, so she's going to make herself some microwave mac and cheese. And she runs the microwave for about an hour and a half with the door open. Takes a while to cook the mac and cheese. All right, you with me? She gets up tomorrow morning and she's shocked to see that the radiation has caused her to mutate. And she's now twice as big as she is right now. And she's grown in proportion. Okay, so she's not like some freaky skinny 126-inch tall freak show. She looks just like she looks now, except she's 126 inches tall.
Yeah, I don't think.
Okay.
double.
By the way, that's 10'6". Okay, she would even, her head would hit the ceiling. The question for tomorrow is, how much will she weigh, and how much will she be able to bench press? And we can calculate this exactly based on the fundamental theorem of calculus. So what we're going to do tomorrow is we're going to start by asking for guesses as to how much she weighs and how much she can bench press. I will give you one hint. It's not the same. Okay?
Really?
Thank you.
Everybody have these numbers down?
Yeah.
Good. I'll unlock the next day's homework. You can start on that, and then we'll pick up where we left off tomorrow. Have a great day, everybody.